Good day, viewers. You are welcome back to Tindanious Maths and Science tutorials. If you are new here, kindly share, like, subscribe, and comment for more interesting videos regarding special or major topics so far as maths and science is concerned. Today, we are going to learn about the proof of the Euler's formula without using or employing Taylor series. If you are new here, kindly visit my previous lecture videos where I've dealt with Euler's formula as a topic into details, and I promised you that everything is well explained. Now, we already know that e to the power I theta equals cosθ plus I sin theta. Yes. So let's look at the proof. So now, let a complex number z represent this expression. Okay. So let's say let z be equal to cosθ plus I sin theta, this way. So now let's take the derivative, okay, of this function with respect to theta. So this becomes dz over the theta is equal to, well, so you differentiate the whole of this. So this becomes, so when you differentiate cos theta, when you differentiate cos, you get what? Negative sign. So you have negative sign theta plus, you have I there, and when you differentiate sign, you get what? Cos. You have cos theta. So now, by rearrangement, this is the same as dz over the theta is equal to, so by rearrangement I have I cos theta minus sin theta. Is that also? Yes. So now remember when we're dealing with introduction to complex numbers, we learned that I squared is equal to what? Negative 1. This. So now wherever I see this negative, I will put what? I squared over there. It's just the same thing, okay? So substituting this into this, I will have this dz over the theta equals, I have I cos theta, then the minus here is the same as what? Positive I squared. So I have plus I squared what? Sin theta. Now this is the same as dz over the theta is equal to I and I. You see, you can see I can also see what I here. So this calls for factorization. So I'll factor I out. I have I, then into bracket, I have cos theta, then plus I sin theta. This way. So now, we know that but this expression cos theta plus I sin theta is equal to what? Now let's come here. Okay, here you realize that cos theta plus I sin theta is equal to what? Complex number z, which is equal to what? Z. So wherever I see this, I'll just put what? Z over there. So finally, I'll have dz over the theta is equal to, I have I, then times what? The z. This is what? Z. Okay, so we have this. So now, I have dz over, so I can just do this, I can multiply here by dθ, okay, which is equal to, I have I, z, then dθ. So when I multiply here by dθ will cancel dθ, okay, so this remains this way, then dθ comes here, alright? So I'll divide both sides by z, here also by z. So z cancels z, I have dz over z is equal to, I have I times dθ. So having done this, so now we will take integral of both sides, okay? So I'll take integral of both sides this way. So this is the same as 1 over z multiplying dz, which is equal to, I have I dθ. Why this? 1 times dz gives dz over z, okay? So whenever you want to take the integration, okay, of functions this way, 1 over an expression, provided that expression is a linear expression, it becomes lim. So whenever you have, let's say if you have integral of 1 over a, this becomes what? Lim of what? Of a. That's how it goes. So I have something like to the power a to the power 2. This won't hold because I said the denominator should be what? Should be a linear. This is quadratic. So now you have 1 over z times dz. So this becomes what? Lim, then absolute value of what? Of z this way, which is equal to. Now when I integrate this, I'll have what? I, then theta, then plus my constant c. Remember, this isn't indefinite integral. This is what? This is indefinite integral, not definite. So I'll have to add what? An arbitrary what? Constant. So this constant is the constant of integration. Okay, so having done this, then you take exponential of both sides. Okay, so where e or where e is the exponentiation. So I'll multiply both sides by e, which is this raised to an exponent of this. So this becomes the exponent. So I have lim, then the absolute value of z, which is equal to whatever you do to the left hand side, do the same to the right hand side. So I multiply here by e raised to an exponent of this. I have I theta then plus c this way. So you know that. So the exponential function and logarithmic function, okay, they are inverse functions, okay, in the sense that the exponential function nullifies the logarithmic function. So this becomes absolute value of z. You get, so e and the lim, they nullify each other, so you have z, which is equal to, you have e to the power I theta then plus what? Plus c. And now, according to the law of indices, whenever you have the same base multiplying, this is the base raised to an exponent of, let's say you have x, then you have here y. Because the bases are the same, you pick one, then you add what? Their powers, x plus y. So you can also split this using what? The law of indices, okay? So this is the same as the absolute value of z, which is equal to e to the power I theta, then times e to the power c. Why this? The same base, right? So if I pick one, then I add I theta plus c. This way, they are the same. Okay. So we have this, okay? Remember, c is the constant of integration. So let me label the constant of integration as c1. We have c1 because in the course of the proof we will be getting another constant, okay? So let's come here to the board this way. So I have this. So this becomes C1, this is also C1, this is C1, and this is C1. Okay, you can still maintain this, but I don't want us to be confused in the course of proving the formula. Okay, so having said this, okay, so say let the whole of this, okay, is a constant. So I can say let C2 represent the whole of the constant, okay, e to the power C1 this way. So I can say that the absolute value of z is equal to, you have e to the power I theta, then times e to the power C1, but e to the power C1 is the same as what? C2. Okay, so this is the same as this. C2 times e to the power I theta. Okay, so now I want to make z exactly. So I have z is equal to, because of the absolute sign here, this becomes plus or minus C2 multiplying e to the power I what? Theta this way. So I can also say that let plus or minus C2 is a constant, okay? So I can simply say that let C be equal to plus or minus C2, okay? Because C is an ultimately arbitrary constant, okay? So I have Z is equal to plus or minus C2, where plus or minus C2 is the same as C. So I have C times e to the power I, then theta. Now, obviously, or by intuition, C is 1, okay? But you can't conclude that way. So what do we have to do? So you have to show that C is equal to 1, okay? So now, we know that from Z is equal to cosθ plus I sin theta. Why this? Come here. Remember that we said let what z equals the whole of that. Okay. So now, to prove that c is equal to 1, we just say that let the angle theta be equal to 0. Okay. To think you can choose theta is equal to any value, but if you make theta 0, it simplifies what your calculations here. So when theta is equal to 0, I'll have this z is equal to cos of the angle 0 plus I then sine of the angle what? 0. So I have z is equal to cos 0 gives what? Gives 1. Is that also? Then plus I then sine 0 gives what? 0. So I have z is equal to 1 plus 0. So therefore, z here is equal to what? 1. Okay. Okay. So since z equals 1, we know that z from this, we know that z is equal to c times e to the power I theta. Let's come here. Remember this. Remember from here. Here. It says z is equal to c times e to the power I theta, right? Okay. And we have it here. And z is equal to 1, right? So by substitution, z is equal to 1 is equal to c times, remember, you can't just compute c is equal to 1. Alright? I have times e to the power I multiplying theta. Remember, we said the angle theta is equal to what? 0. 0 here. Why 0? Come here again. Here we said theta is equal to what? 0. Alright, okay. So here we have 1 is equal to c, then times e to the power I times 0 gives 0. Okay, but we know that e to the power 0 gives what? 1. So we substitute this into this. So we have 1 is equal to c times e to the power 0, which is equal to what? 1. This way. So I have c is equal to what? 1. Is that not so? Okay. So having done this, we can say that we know that from here, okay, from here, let's take it from here, you know that z is equal to c times e to the power I theta. So we have z is equal to c. What is c? C is 1. Then times what? We have e to the power I theta. So I have z is equal to what? E to the power I theta. Is that also? Remember again, we said but z is equal to what? Cos theta plus I sin theta. Remember this from the onset here. Remember, we said what? Let z is equal to cos theta plus I sin theta. Okay. So having done that, so we can say that. So I can say therefore this z, which is equal to e to the power I theta, it says z is the same as this. This is the same as this. So I can therefore say that cos theta plus I sin theta, which is the same as the z, equals what? E to the power I theta. So therefore we can say that e to the power I theta is equal to cos theta plus I sin theta. Viewers, this is the end of the lesson. So far as Tindanious maths and science tutorials is concerned, we are going to learn a lot. Stay safe, stay blessed, and I'll bring another video regarding the proof of the Euler's formula. But this time around, we are going to prove the Euler's formula using the Taylor series.